Hello everybody, welcome to my workbench again on part 7 of our 2-band, how you call it, regen, radio, rebuild or build. In front of you see the switch. I cleaned them up, and there is an, have a look, an 18p and an 100 picofarad capacitor on there. So I just didn't solder it on there yet. And I have a capacitor here from 22 and one from 82 picofarad. Additional to that, I went to the shop. I did to get my VRs or potentiometers. On top of that, I did buy some electrolytic capacitors, plus some chassis parts to solder on. So anyway guys, this is the crucial part of this radio. Now we have to fix that are the series capacitors. So that is from the coil to the tuning capacitor. Yes, and then we have two additional capacitors that going on the side of the tuning capacitor onto ground. So and the other part is to get you can't really see that. Well, I have to zoom out and refocus. Hold on. Yeah, come on. So there you go. Refocus this again. Okay guys. Then we have to have those two wires. This is the 80 meters and this is the 40 meters. I have to connect it up to the switch as well. This is a very crucial part. Now I'm going to confuse you. You know, we have these capacitors here. The series capacitor is 18p and 22p. No, 18p and 100p picofarads, and the parallel capacitors on the tuning capacitor is 22p and 82p picofarad. So now we're going to confuse you. We have to calculate it that, and I give you a warning already. We have the capacitance in the coil, we have capacitance in the wiring, and we have capacitance in our socket or valve from you have to take into account. Anyway, I'm going to fit those capacitors. I'm going to solder them on. I will fit the switch. I will fit the wire to the tuning capacitor, and I will fit the coil onto it. I will fit those two capacitors and get them to ground. Then we get our coils to ground, and then we have our two taps to the tuning capacitor and to the valve itself. So that's what we have to do next. And there you go. And then we're going to try it to dip it with our meter, with our grid dipper. There he is, our grid dipper. See, we can see him. There he is. That's our grid dipper. We have to do it with that. And then we can see the resonance frequency of our coils, how deep they go down and how high they go up. So what we're actually looking for in our 80 meter band, we're looking at 3.5 and 3.8. And for our 40 meter band, we're looking at 7.0 and 7.5. We have there the amateur band, and also have a broadcast band, so I want to include that in there. So, but don't be surprised if it doesn't work out. Now I got you. Now it really can go. I don't know where it goes. Hopefully it is on paper. Don't forget, it is on paper. In theory, this is okay. In practical terms, this can be totally different. So it actually what it comes down to, boils down to, is you have to try it. there's no way around this. You have to try. Even if you know for sure on paper that are the capacitors you want, it still can be wrong. It still can be way off. So we have to see what they're all depending on our coil, on the capacitance here, our wire capacitance, and on our valve capacitance. That can have a great influence. For instance, if you have, I just give you number 12P in this coil, that can move your frequency up for much higher. You can, instead of say on 80 meter belts, you can go up to 3.4. So that's high. Oh, what are they going to do then? Well, they have to increase the capacitance. That's what you have to do to get them down. You can do that in two ways. You can do that on the coil. In this case, you can forget that because you have two taps on there. You can't do that. So the other side is to get more capacitance on the side on the capacitor, on the tuning capacitor. Having said that, then ultimately will change also your series capacitors. So what I'm on about now is you're never going to achieve probably 180 degrees tuning, 3.5 left, 3.8 on the right. You shouldn't be surprised if you're somewhere at the top here on, say, full capacitance at 3.3, something like that, megahertz, and go on top to 3.9 or something like that. I don't know, I really don't. I'm just guessing here. And your guess is as good as mine. So then you will ask yourself, well, bother all to calculate it all. Well, the point is, you have to start from somewhere. If you don't have a set point from a starting point, then you are nowhere. You're not even know where he's going. If you leave it off altogether, this will probably tune to nearly 8 megahertz. From the very bottom, 3.3, something like that, will tune this. I will look at that. At my computer I have a program here. I can tell you what this will be. Hold on. Yeah, of course, we have 25 microhenry at the 50. And what will that be? 40. Okay, there we go. Yeah, that's about right. Now, again to see 25 microhenries, and I put 100 picofarads from across that. I come out on 3.183. Yeah, and my minimum capacitance will be approximately from this tuning capacitor at 8 picofarads. So I put that on 8 picofarads. Yeah, then I'll have 11 megahertz. So you can see where I'm going with this. So we're going to do something about it. We cut the top end off and we cut the bottom end off. That's what we're trying to do. And then spread that 180 degrees over our tuning capacitor. Now you're totally confused. Anyway guys, to make a long story short, we're going to try this. We're going to fit the capacitors, put them in. Connect everything up, connect the wires up from our coil, connecting up our tuning capacitor, make a connection to the valve socket. Yeah, and that's where we put in 1 megahertz and 1 mega ohm resistor and our 47p coupling capacitor there. And then we hope for the best. That's where I'm going to stop the video and try to get that all into place. So I'll see you later. Hi, welcome back guys. Well, I'm in some progress again, so you have to excuse me. I'm not going to solder this on camera because it is, the video will be too long. You can see here our parallel capacitors for the tuning capacitor. We have here the wire on this side. Can you see it? Yeah, this is the wire from the capacitor, and on that side, in series with that, you have the connection to the valve. Alright? That's all there is to it. The only thing we have to do next is drill some more holes in that chassis, get everything into place, fit this switch, which gets in there. We'll have to scratch those wires clean so you can solder onto the switch. I'll leave that to the last bit, because that is very definite. If I connect that on, then we can't get the switch off anymore. So what I will do now is to scratch the wires clean and just put some solder on it, and then get a hole in down here to connect one of those strips on there. So I have to connect the capacitors on there, and then on this side with the chassis I have to drill another hole. I have to turn the socket around, believe it or not, since it doesn't work out that way. So I have to turn it around. It's about, let's have a look, 180 degrees. I have to turn it around and drill an additional hole for this little wire here. So that's where we are at the moment. Then we can connect everything up onto the tuning capacitor, and if we also have done all that, we have done all the necessary things, then we start off dipping our coil and see where it's at, and then hopefully it will work out as we expect. It will work out. So anyway, so guys, that's for now, for the moment, and I will proceed with drilling those holes and connecting the switch and turning that socket around and so on and so on. Still all done on that one. Then I come back to you and then we'll do the dipping together, alright? Hi guys, welcome back. Well, I was very curious, so I went ahead of myself. Merely because of shortening the video actually. Actually, I built it all up. The only thing I didn't do is connect it up to the tube socket. I didn't put in the resistors, I didn't put it in place, I didn't put in place the capacitors. So all the loose ends are still there, so but we're going to measure. And I have it's set on 40 meter band. Yeah, and I have maximum capacitance here. So I will switch my dipper on. You can see probably, bit of luck, you can see 7.7, and if I go back you can watch the meter. Hold on. What's going on now? Okay. Hold on. Something is wrong. I don't know. Just it worked just now. So we put the switches out. Switches got to the right place. And he is out. Right. Okay, should do. He should do though. Let's have a look. There it goes. I have a dip on 7.7. So that's the lowest frequency. 7.7, but I didn't connect up to tap that up, and I didn't connect up onto the valve of the grid. So that's still missing, but you can see he's in the area. He is too high. There you go. Something is not right. I know what it is. I discovered it already. It's not soldered on properly. Oh, that can happen. Anyway, we're going back 7.6. So as soon as we connect up the valve and we connect up the tap from the coil, then the frequency will drop. Okay. Now I put in that's 80 meter band, so that will be 3.5, 3.8, yeah, and we must measure that as well. So measure that as well. I will put them on 4.2, yeah. So let's get this bit lower, so. Yeah, the same trouble. Yeah, it should be okay. There's a bad connection somewhere. There you go. See? It's a 3.8. His max capacitance is 3.8, so it's too high as well. So only what I have to do now, chaps, is to check our soldering points. That's the only thing you have to do. Bad soldering, bad boy. Anyway, you can see it works. It is near the frequencies we want. How it is going to work out, we don't know that yet. I told you it could be different. Anyway, we have to connect all those wires up. Don't accept that on here. We have to connect those two up. He goes to 0.3 and this one goes to 2.8. So I have to connect that up with the resistors in place and the capacitor. And then we will find out what's going on. Okay, then it can be different because the valves will be in there but it's not powered up. So that can be changed as well. Shouldn't be, but it could be. And what it comes down to, it boils down to, you probably have to change those capacitors here. Smaller, bigger, I don't know. You have to see if we can do that with smaller capacitors. So you have some soldering points here, so I can put parallel the capacitor and can see which works out best. That's about it, guys. I think I have to see how long the length of this video is, how far we're going with this. Yeah, I think it will be a lot of work to get the valve going. You have to see to my transformer and so on and so on. Perhaps I could use my my power supply in the laptop power supply. Get some voltage on that valve. I could try that, and then we can see where he oscillates. Okay, that's perhaps an idea of what we could do. Yeah, let's try that. We have to power up our valve as well. So yeah, let me think about that and then I'll come back to you. Okay. Hello guys, welcome back. So like I said, I think about it. So it's not very functional if you starting getting parts in and you don't know the schematic. So I went on and made a provisional schematic, and as you can see, it is on the bench. Let's see if I have my pencil to point something out to you. I don't see it anymore, so it doesn't matter. So you have here, you have our antenna separator, actually an amplifier, but it's not really an amplifier, it's actually a cathode follower. So your signal coming in and will be on his capacitor go into your antenna winding from the coil. And you can see our two capacitors in series and our two capacitors parallel on this tuning capacitor. So it actually, now you have your connection to the grid of the ECL82. And what I'm on about is this resistor, this capacitor, and also this capacitor. So well, if you want to do all that, and then well, you have to finish the job. Actually, you should actually get the whole shebang working. I didn't put the proper values in there yet. So, but it's just to give you an idea where it was on about. So yeah, the schematic is not finished yet. Anyway, as I said, it is provisional, and yeah, your rectifying valve is not there either, so I didn't put that in there yet. Anyway, we're now at the point where we're going to check how this is going to work. I have to move the camera a little bit. That's better. Anyway guys, we have to work out that what it's going to do with the valve in it, and see without voltage. We do that in the next video, I suppose, and then you can follow along, and yeah, and then we see from there. Anyway guys, we are at the cusp of having a working radio. This is what this is all about. If this is not right, guys, this radio won't work. It's as simple as that. So if this, we have to get this right first. Then we see to the rest, otherwise we won't get anywhere. So there must be also an antenna plug in the back here somewhere, so I have to do that as well. I've put in the new potentiometers, or VRs, of variable resistors, put them in there. I have to shorten that axle. I won't show it away, so I will dremel that off, and we'll see, perhaps I will get some support in there as well. I don't know what they're going to do, if I put them in a nice box or anything. I'll have to think about that. I don't know, I'll have to see. Anyway guys, I'm going to conclude this video, and we'll see you back on the next video. I say thank you for watching, and if you like the video, give me a thumbs up, and then I know I like it, you liked it, and otherwise I'll refer you to my band spread video, what is on the net, and if you really want to work it out, you have to put some effort into it, otherwise you're never going to understand how that works, okay? Anyway guys, I'll see you next time.